Astronauts orbiting the Moon captured this solar eclipse on April 6, 2026, a moment of totality that lasted nearly 54 minutes. This was the central event of the Artemis II mission, marking humanity's first return to the lunar vicinity in over 50 years. The crew's photographic record begins as the Orion spacecraft initiates its 7-hour flyby of the lunar far side. At 6:41 p.m. Eastern Time, the crew watched as the Earth began to physically disappear behind the lunar horizon. On the day side, cloud systems swirl over the Pacific, while just a few hundred miles away, the night side is shrouded in complete darkness. Minutes before it vanishes, our entire planet appears as nothing more than a thin crescent of light against the cratered edge of the Moon. This Earthset represents a physical threshold. For the next several hours, the crew is cut off from any visual link to home, isolated by the mass of the Moon itself. As they move over the far side, the spacecraft crosses the terminator, the line where the Moon's day side meets the night. This technical image shows how sunlight hitting the surface at an extremely shallow angle forces the terrain to cast long black shadows. By measuring these shadows, researchers determine the exact height of ridges and craters that would otherwise look flat under direct sunlight. Because the Moon has no wind or water to drive erosion, these shadows reveal jagged geological features that have remained physically unchanged since they were formed billions of years ago. This view captures the South Pole Aitken Basin. It is one of the largest and oldest impact sites in the solar system, preserving a record of the Moon's earliest history. In this technical capture, you can see how scientists determine the age of these basins. Here, newer crater chains cut directly across older impact sites, establishing a clear sequence of events. Looking at Vavilov crater, the contrast is even sharper. The smooth interior floor was formed when the surface rebounded after impact, while the rim remains rugged and fractured. Reading this landscape provides a timeline of cosmic impacts that has been entirely erased from the Earth's surface by billions of years of weather and plate tectonics. As the flyby reaches its midpoint, the spacecraft's trajectory brings it into a precise alignment with the Moon and the Sun. For a brief window, the Orion spacecraft, the lunar far side, and the distant crescent Earth all appear in the same frame. Inside the spacecraft, the crew prepares. They put on protective eclipse glasses to watch a familiar terrestrial event from a completely different perspective. Totality begins as the Moon moves directly between the spacecraft and the Sun, blocking all raw sunlight. For nearly an hour, the crew could see the Sun's glowing corona. The lunar surface below wasn't completely dark either. It was lit by Earthshine, the faint light reflecting off our planet. This 54-minute alignment only works because of the spacecraft's high-speed orbit. From the ground on Earth, a solar eclipse can never last this long. As the spacecraft remains in the Moon's shadow, a single bright point of light becomes visible in the dark sky. This is the planet Venus, proving that the wider mechanics of the solar system remain visible even when the Sun is suppressed. The eclipse ends as the spacecraft's orbital speed finally carries it back into the sunlight. Raw sunlight breaks back over the dark curve of the Moon, ending nearly an hour of total darkness. This final wide-angle view captures the entire landscape the crew observed during their 7-hour journey across the far side. These images translate ancient geological data back into a human perspective. If you were standing there, which moment would you choose to witness? The Earthset, the far side, or the eclipse?